Hello, good evening, everyone. Our lesson title today is Interference of Waves. Interference of waves is defined as a combination of two identical waves traveling the same direction overlap. Or this is when two waves moving the same direction overlap. That's how simply you can define interference of waves. So this diagram here you're seeing is going to describe interference of waves. We have two taps here that are going to cause disturbance on the surface of water, and we're going to see what happens when you increase the frequency and when you increase amplitude. What happens when the frequency is minimum? What happens when the amplitude is at zero? Let's go. Now you see that when you maximize frequency, the wavelength is minimum. The distance between the consecutive crests is small. The wave has the highest number of oscillations per unit time, and the interference patterns have more closely spaced nodes and antinodes. That's when the frequency is maximum. What about when frequency is minimum? When frequency is minimum, the wavelength is maximum. You see now the wavelength is very big. The distance between the consecutive crests is also large. The wave has the lowest number of oscillations. Now the oscillations are very small. The interference patterns have widely spaced nodes and antinodes. That is now the effect of frequency on this wave. Then what about the amplitude? When the amplitude is zero? When the amplitude is zero, there is no wave. The wave cancels each other. When amplitude is zero, the wavelength, there is destructive interference occurring. The waves cancels each other out, resulting and the resulting wave has zero displacement from its equilibrium. That's when the amplitude is zero. But what about when the amplitude is maximum? When the amplitude is maximum, the wavelength has the highest displacement from its equilibrium position. The wave has the greatest energy. The interference have the large amplitude at the point of constructive interference. The wave have the most pronounced crests and troughs. Then let's look at when we increase the separation of the points of disturbance, what happens to the interference of waves? When we increase the points of disturbance, the interference patterns become more complex. And what happens when we reduce the distance of separation, of the disturbance? You see what happens now on the wave when we reduce the distance. The amplitude of the resultant wave decreases. The wave pattern becomes less complex and less intense. the wavelength may increase, resulting in less frequent wave pattern, and the wave pattern will no longer exhibit interference. You see now there is no interference occurring there. So that's all about I can say about the interference of waves. Don't forget to subscribe, like, and share as we're waiting for another video. Thank you.